Hello everyone. Thank you for joining today's video. Today's topic is going to be around the bulkhead pattern and how it is actually implemented and demonstrated in WSO2. So I'll start with the diagram of what a bulkhead is, and if most of you would already know, the bulkhead were actively used in the cargo and shipping industry. But let's get into some of those details. So this is actually a picture of maybe a small ship or a small boat where there are many vertical compartments that are created in the boat to actually protect the boat from any kind of flooding when there is one. This also reduces the possible damage that can happen when a particular compartment is actually flooded. So this actually isolates and compartmentalizes any of the flooding within the boat. Now it's true if more than a certain number of compartments are flooded, of course, the boat can actually sink. And that's pretty much what happened with the Titanic. But let's try to take that into our software industry. Now let's assume that WSO2 is a boat and it has quite a few compartments that are there. Each compartment has been dedicated a set number of threads that can be used for the execution of services. So as you can see, there's a compartment that has a dedication of a certain number of threads for service 1. A certain number of threads have been allocated for service 2, and so on and so forth. So there are ways to control how many threads can be allocated for a particular service, and that's mostly done with a combination of the domain and port. So a combination of a domain and a port is allocated a certain number of threads, as well as the total number of threads that can be used for execution is also there. Now bear in mind what I'm referring to in the case of WSO2 is the blocking calls. Non-blocking calls work on a slightly different principle, which is probably going to be another topic. And if you'd like to know about the circuit breaker pattern, which is also there in WSO2, you can look at the other video which I've done just before this, which talks about how a circuit breaker pattern actually works. Now, there isn't much of how this is actually implemented, but I'll get into a quick demo. And in order to understand the demo, it's good to understand the whole ecosystem. So we start off with WSO2 and proxy services that are hosted on WSO2. If you'd like to know about proxy services and go through other tutorials of WSO2, a friend of mine has done an amazing job at building a lot of tutorial on WSO2. I'll give the details of the videos in the bottom of the description. So we start with actually a native service. As you can see, this native service is depicted as a fast service and it takes 10 milliseconds to execute. So I have done this by hosting the service as a mock service in SOAP UI. And as you can see, the domain name has been consciously chosen as hellosite2.com. This just resolves to my local host, my laptop, where the SOAP UI proxy is running. Now, if you recollect previously, I said that the number of threads dedicated is a combination of the domain and the port. Therefore, I've chosen a site called hellosite2.com, which actually has a native service running with a execution time of 10 milliseconds. This native service can be then consumed from the proxy service as localhost 8280 where WSO2 is running, and the service is called fast service. Now there's another service which is actually a slow service, and here the execution time has been consciously chosen as 20 seconds to show actually that this thread is busy most of the time. And here the site is hellosite1.com. So for just to keep in mind, just always keep in mind that hellosite1 is the slow one and hellosite2 is the fast one. And of course, for the slow site, there is an equivalent slow proxy service. So this is the basic foundation of our demo setup. Now we will actually see how we execute these services and the response time that would actually come. So ideally, if you wouldn't have a bulkhead pattern implemented, if there are a handful of slow services executed, then the fast service would actually be stalled. That's because there is no dedicated set of connections for a particular native service. However, in the case of WSO2, there is a dedicated set of services, dedicated set of connections or threads allocated for a slow service, as well as for a native service, and so on and so forth for all services. Therefore, no matter how slow the slow service is, or no matter how many requests come into the slow service, the fast service can still continue to execute as long as the number of connections are available to execute a fast service. Let's move into the actual demonstration using the SOAP UI. Okay, so we are in SOAP UI, and I think SOAP UI is pretty good enough to explain what we're trying to demonstrate. So as you can see, I have a mock service over here. It's running. I have the actual mock services hosted. So I'm going to go to mock service 1. That's hello site 1. If you remember, hello site 1 is supposed to be the slow service. Okay, so it's executing. I'll pull out mock 2, which is actually hello site 2. This is supposed to be the fast service. And when I execute it, you can see it responds in 1 millisecond. I haven't put in any delay. The reason why hello site 1 is slow is because actually I put an intended delay of 20 seconds. To prove the point, I'll reduce it to 20 milliseconds. And you can see that if I executed it again, this would now respond in a couple of milliseconds. So I'm going to put it back to 20 seconds and show you that it actually takes 20 seconds to respond. So that's the mocks running. Now these requests don't go through the actual WSO2 enterprise integrator. These are considered as the native services. You have a slow service as mock 1 and a fast service as mock 2. I'll pull out a fast service. So this is the fast service, which actually in turn calls the mock 2 to demonstrate that actually it is working fast. So let's call fast service 1. You can see it actually made a call and responded in a couple of milliseconds. If I remove the response over here and make a call, it's actually returning back this response, which is pretty fast. And I have another fast service, just another copy of it, fast service, just to show that I can keep running as many times I have want to do it, and it would just execute without any problems. Now moving on to a slow service, I have a slow service over here. That's one copy of it, and if I were to execute it, it would call the slow mock service, and in turn the response would go back in 20 seconds. While it's executing, I'll open up the next copy of it. It's the same thing. It's 8280 and the slow service over here. Now this will respond back in 20 seconds. Let's give it that time. So you see it's responding 20 seconds and it's actually taking 20 seconds to execute. And I execute the next one. I could just execute this, but it doesn't matter. I just execute the next one and it actually would respond in 20 seconds. So what I'm trying to demonstrate over here is, if the slow services are keeping the enterprise integrator busy, then ideally any of the other services, the fast services, wouldn't execute as expected. So I could minimize the mocks. They are not relevant anymore. So I just kept them minimized. Now, if you see, and if I show you the fast service, so these 4 are the only ones that I need. So if the slow services are keeping the enterprise integrator busy, then ideally none of the fast services would execute. But that's not the case. WSO2 enterprise integrator has the bulkhead pattern implemented. Therefore, if there is a rogue service such as the slow service, then it would compartmentalize and isolate the threads relevant to it and there are a certain set of threads that are allocated to the fast service. Which means, okay, and currently what is the configuration? What are the number of threads? That's the question that usually comes up. And this is the configuration for it. As you can see over here on the HTTP transport, there's also HTTPS, but I'm just going to use the HTTP transport. I'm going to set the maximum number of default maximum connections per host as 1, which means that at any given point to a particular domain and port combination, only one connection is available. And this is only for demonstration purposes. We could tweak it around and see what happens. So now let's see. I execute this. It takes 20 seconds. Now, if in fact there is only one thread and I execute the next slow service, then this execution time should only be 40 seconds. That is 20 seconds after the first call, the next call gets executed. And that's what is actually going to happen. So we see over here 20 seconds. And here it is no longer going to be 20 seconds. It's going to be close to 40 seconds because one thread has been allocated over here and the second thread is actually waiting for the execution of the first thread to complete. So 20 seconds later, 20 seconds for the execution time, and you should see something like 38 or 39 milliseconds, 31 seconds. So as you can see, it is additive. It just waited for the first service to execute and then the next service actually kicked in. So it's only allocating one thread at a time. On the contrary, if you see for fast service, because it just takes a millisecond to execute, you can fire quite a few number of them and one connection is actually executed and returned back to the processing of the remaining requests. Now to see the bulkhead in action, I'm going to keep the slow service busy and then fire as many fast services as I want. As you can see, there is absolutely no blocking for the fast service. It has a dedicated set of threads, and it's actually executing as expected. And you would see that the slow service is still executing and trying to actually complete its 20 seconds, which it did now. Now I demonstrate again the same fact by executing it once. This would take 20 seconds and the next one would take actually 20 seconds after that, which you could also see from the log. Let's just wait for the logs to come. So the slow service, the first one has executed. It's allocated a certain number of threads and it's just one right now set up. So it's going to take 20 seconds and then this service is going to wait for the first service to execute, complete, and then would kick in the next one. So yeah, as you can see at 2018, this thread has finished. Ideally, the next one should complete in another 20 seconds. Let's give it some time. So you can see over here, it's still executing. If it was indeed, yeah, you see 38 seconds and here it completes at 1834. So with this, I'm proving the point that it in fact is dedicated one thread for it. What I will do now is I'll increase the number of threads for a particular host and port from 1 to let's say 5 or 6 threads. Thereby the slow services can actually get more than one thread to execute. For that, first I'm going to actually stop WSO2. Now I'm actually going to increase the number of threads. Let's say I'll put it to 2. You could increase it to a higher value. I mean, HTTPS is also not required, but let's say just for the sake of being absolutely correct, I'm increasing it. And I'm going to actually start the enterprise integrator once more. It takes a couple of minutes to come up. Now, what you would see different over here is if I were to fire these two slow services back to back, the execution time of each one of them would be almost 20 seconds, which means that now 2 threads are allocated for the domain hello site1.com, whichever was the slow service, and two threads are dedicated. Therefore, I can run 2 concurrent requests. That means even if your slow service becomes rogue, you are allocating, a finite number of connections, which is now controlled to 2, and your fast service would still continue to execute. So let's see if the enterprise integrator is up. It's still coming up. Let's give it a minute. it's almost up. Yeah, so it's deployed the application. Yeah, it's now up and running. So let's first do a couple of calls for the fast service. As you can see, the fast service is working perfectly fine. Now I'm going to call the slow service one after the other. The expectation is that this is going to be 20 seconds and this is going to be also close to 20 seconds. So let's say 1, 2, and now we'll wait and see the logs. So now there is one thread allocated for this slow service and there's one thread allocated for this slow service because we just increase the connections per host combination port from 1 to 2. So the bulkhead comprises of, you see, yeah, so it's back with 20 seconds and 20 seconds. And the execution completion is almost close to each other. That's because 2 threads were allocated for the domain and port combination, or the native services domain and port combination. So yeah, so basically this is what I was trying to actually demonstrate, that the bulkhead pattern is activated now and you are actually controlling how many threads you want. This could also be elaborated if you were to run a JMeter script, and you could say if you spin up 2 threads continuously back to back, they would continuously execute every 20 seconds. And at the same time, the fast service is absolutely not affected by your noisy neighbor. So no matter how slow the slow service gets, the fast service is just going to continue with its own set of threads. I hope this explanation was good enough to demonstrate the bulkhead pattern. So I hope it has been clear what we have done. Just to summarize at the end, we spinned up a fast service as a mock service on SOAP UI with around 10 milliseconds. We spinned up a slow service on SOAP UI that has that takes around 20 seconds. We had 2 proxy services in the front of WSO2. We initially dedicated 1 thread for the slow service and demonstrated that subsequent executions of the slow service took 20 seconds and the next execution took 40 seconds, that's 20 plus 20. However, the fast service was unaffected by the response or execution time of the slow service. We later then went and increased the number of connections to the slow service from 1 connection to 2. We re-executed the slow service, and now this time 2 connections or 2 requests at the same time, and both of them took actually 20 seconds each. This proves that we can control, let's say, the depth and width of the bulkhead in our WSO2, let's say, theoretical ship space. We're actually increasing and decreasing the size based on what are the SLAs of the native service. I hope this explanation has been good enough to understand the bulkhead pattern and how it actually works. And this diagram or this picture is courtesy to the shipping industry, which actually shows well how each compartment is isolated and watertight, such that it doesn't spill off into the other containers. Thank you so much for joining the video. If you have any questions or any clarifications on how to control some of these things or any other follow-up questions, please do share them in the comment box. If you haven't subscribed to the channel, please do subscribe. Thank you.